Hey everybody, it's Grant Sims at Chief River talking security. Today we're talking about XSS or cross-site scripting. Wanted to just give a high level on XSS, and specifically today we're going to be talking about reflected cross-site scripting and what mitigations along the path could you implement to prevent that from occurring on your web service. So just to start off up at the top, this is how a common reflective XSS starts. So a user is interacting with a browser, and in a non-malicious way, they send input. Let's just say it's a web server saying, please provide your name, and you type in your name, and then the web server reflects that back to the browser. It takes your input and then just sends it right back to your browser and says, hey, Grant, in some HTML here, and presents it back to you. Nothing bad about that from just a typical standpoint, but now let's see how bad guys can abuse that. So what they're trying to do is get your browser, to execute some type of script that they wrote. So let's just take a bad guy. And a bad guy, he's investigated this website. He's noticed that you can inject JavaScript, that it is reflecting user input back. And he formulates a link that is automatically sending this request to the web server, inputting what the website is expecting a name, but instead inserting a script. And in this case, a common use of reflective XSS is to steal sensitive data. In this case, we're saying steal a session key. Now, this script isn't really going to do anything, but it's just a representation of what they're sending, saying, hey, this guy's going to craft a link that creates a post to this web server, and instead of sending a name, he's going to inject a script that is looking to steal session keys from your browser and then send those session keys to a web server or web service that this bad guy's hosting. So he's figured out, he's investigated the web server. He understands that there is a possibility for reflective cross-site scripting. He's crafted a unique link that will automatically post this script into that input and then be returned to the browser. And he crafts this in a phishing email. He sticks this link in an email and he sends it to the user. And the user is like, oh, he's not very well trained. He doesn't realize this is a phishing email. And he goes on his browser and he clicks that link. So when he clicks that link, he's sending that request to the web server unknowingly, and he's sending that script in there in place of where the web server was expecting a name. And the web server's turning around and just reflecting it right back to his browser. And now, when he sends that back to his browser says, hey, this is actually JavaScript. I'm going to run this JavaScript. And in our use case that we're talking about here today, this evil script over here that is being run on our browser is actually looking into our session keys that are in our browser from existing, websites that we've authenticated to and logged in, and it's then sending those to the bad guy. Now the bad guy has our session keys. He, ditches this attack and he goes straight to those other web services where we have open sessions via those session keys, and is now interacting, as us. As the good guy over here, and is doing bad things on our accounts. So let's flip over to the protection side of things. So let's take that again. The bad guy's over here. He's formulated this. He's sent the phishing email with this bad link in it. First of all, you could have email protections. Lots of vendors out there, lots of systems out there that do this, that detect those incoming links and try to determine if this is a phishing email in general, and two, is there any type of potential cross-site scripting links that are being put within those emails. Next, we could just talk about the users. We could have user training for phishing. This user should be able to look at that email and say, something's not right. I probably shouldn't click that link. But let's just say, it passed our email filtering. Our user wasn't well trained, so they end up clicking that link. Well, on the client side, we could have done some sanitization or encoding or escaping or validation. Basically, don't send anything to the web server via some local code. that don't send the script in the first place to our web server. Let's escape this so a script can't be sent, or let's sanitize it, and it'll never get to our web server. But let's say we didn't have that, so the script is sent over to our web server. What we could do is place a WAF in front, and a WAF, this would probably take some SSL inspection here, or breaking and inspecting the TLS traffic, due to we're looking inside of an encrypted channel, typically on HTTPS. But that WAF could be there to look for these attempts to inject scripts, or to exploit cross-site scripting, and block it before it even gets to our web server. But let's say our WAF rules weren't properly configured, or we didn't have one, so it gets to the web server. Similar to what we did on the client side, we could do on the server side as well. We could take those inputs and validate them, sanitize them, encode them, escape them. Basically make any type of JavaScript that was trying to be injected into our web server. Just make sure it doesn't actually render into executable JavaScript. Now, we could also do that on the output side. So now it's gotten into our web server. We didn't do any sanitization on the input, but now as we're reflecting it back to the user, we could do the same thing on the output side. We could encode it and escape it, to ensure that even if the script got inputted to our web server, as we're reflecting it back to the user, or back to the browser, the client there, that script would not be rendered. So if it does get over here, because of it's being escaped here, you can see I've just added some escape characters. The browser would say, this isn't valid JavaScript, or this isn't JavaScript at all. I'm not going to run it. Another thing on the outbound, we could send content CSPs or content security policies to the browser. And depending on the types of XSS, reflective, stored, etc., these policies could be different. But basically, it's telling our browser, what domains scripts can be loaded for, should inline JavaScript be able to be ran, etc. So depending on what your service is and where your scripts are coming from, if you need to run JavaScript inline, etc., those CSP policies that you send at the beginning of the discussion between the browser and the web server could prevent, once again, scripts from running in the first place. And then to our specific example here of bad guys trying to execute JavaScript to then steal something. In this case, let's just say all these things failed. It was sent over valid JavaScript, and it was going to be running. If we have our sites setting credentials or sensitive cookies with certain flags like HTTP only, what that flag's doing is basically saying, hey, no JavaScript is allowed to interact with this cookie. This isn't meant for JavaScript. That would prevent, even if the JavaScript did run, it would prevent it from actually reaching that sensitive information and then sending it back to the bad guy. So they kind of work in conjunction here, and all these things are kind of defense in depth. And then all the way over to the right here, we need to be looking at our code. We need to be doing some type of, vulnerability checking, static analysis in this case, to check to see if we have any type of, reflective XSS, or really any XSS vulnerabilities in our code, and resolve those. With that too, you can use frameworks that have this built in, like, for example, React, where they do this for you, and basically you have to blatantly bypass it using certain functions to incorporate an avenue for XSS. It's not 100% foolproof, but it does a lot of the things out of the box for you. So hopefully, looking at what cross-site scripting is, specifically in this use case, the reflectiveness, and the use case of trying to steal sensitive data, hopefully you can see the various points at which we could implement mitigations. And once again, defense in depth. The more of this you can accomplish, the better off we are at preventing bad guys from running JavaScript in our browser unknowingly. Hopefully this is helpful. If you have any questions, please reach out, put it in the comments. And once again, I appreciate your time. Thank you so much.